Here's example 5 with right triangle trig. So in example 5 we have given secant of theta equals 4, find the exact values of the following without drawing a triangle. So this is just like examples 3 and 4. We're given a value of a trig function, but what's different here is we're not allowed to draw a triangle now. Okay, so the instructions say we can't use a triangle, so we'll have to do it some other way. And the expressions we want to evaluate here are tangent of theta, cosine of theta, sine of theta, and secant of pi over 2 minus theta. So for part D here, we're going to have to use the complementary angle theorem. So remember, we talked about that a few videos ago. So we'll talk about that more when we get to it though. So anyway, let's do part A, so tangent of theta. Okay, so for part A, we're going to do the tangent of theta. Now we're not allowed to draw a triangle, and all we know is that secant of theta is 4. So is there some other way that we can do this? Is there something that we know that relates secant of theta and tangent of theta to each other? So, well, what else have we talked about so far as right triangle trig goes? We talked about those identities, right? So there's the quotient identities, reciprocal identities, and also the Pythagorean identities, right? So remember, one of the Pythagorean identities said 1 plus tangent squared of theta equals secant squared of theta. Right? Remember that? Okay. So, tangent of theta is what we're looking for. So 1 plus tangent squared of theta equals secant squared of theta. Well, we're given secant of theta, right? It's 4. So this is going to be 4 squared. Okay, so if secant of theta is 4, then secant squared of theta is 4 squared. So now we're just going to solve this for tangent of theta. So tangent squared of theta, subtract 1 from both sides. So first of all, 4 squared is 16. 16 minus 1 is 15. Okay, so tangent squared of theta equals 15. Take a square root of both sides. So then tangent of theta equals, so yes, there's a plus and a minus root, but what's true for acute angles is that for acute angles, trig functions are always positive. So tangent of theta is going to be the positive square root of 15. So tangent of theta equals positive square root of 15. So actually, that thing I just said, let's write that down, because it's a point worth mentioning here. If theta is an acute angle, and first of all, how do we know that theta is acute? Well, we're talking about right triangle trig, so all the angles that we've been talking about, they've all been acute angles. So for right triangle trig, you're just dealing with acute angles. Okay? So if theta is an acute angle, then the 6 trig functions of theta have positive values. Have positive values. Okay. So there's a lot of different ways to think about that, but how do we define these 6 trig functions? We define them in terms of the sides of a right triangle, right? So remember, for we had a right triangle here, here's theta, here's A, B, and C. So when we define the 6 trig functions, we define them as ratios of the sides. Well, since we're talking about sides of triangles, A, B, and C all have to be positive. So if we're going to divide them, no matter how we divide them, A, B, and C, we're going to get positive numbers, right? So the sine of theta, B over C, that's positive. The cosine of theta, A over C, it's positive. The tangent of theta, B over A, that's positive. Okay? So if theta is an acute angle, then the 6 trig functions of theta have positive values. So sine, cosine, tangent, cosecant, secant, and cotangent, they're all positive if theta is acute. So why do we bring all that up again? Because when you take a square root of something squared, you have to take the positive and negative root. But since theta is acute, then we take only the positive root. And why is theta acute? Because we're talking about right triangle trig only. Okay, so anyway, just some subtle details there that we really do have to point out. So got to keep those in mind. So that's part A. Now part B. Okay, so here's the work for part A. That's that. Now part B is cosine of theta. Okay, so for cosine of theta, remember the reciprocal identities said that one of them said that cosine of theta is 1 over secant of theta. Okay? And we're given secant of theta is 4. Okay, so then we can just say right away, okay, cosine of theta is 1 over secant of theta, which is 1 over 4. So that's pretty much that. So this is 1 over 4. Okay. Now how about the sine of theta? Well, the sine of theta, what do we know so far? We know the tangent we know the cosine, and we know the secant. So there are two different ways to get the sine, and I'll go through both ways just so we can see all the details here. So there's a shorter way and a longer way. Let's do the shorter way first. So for part C, we want the sine of theta. Okay. Now what do we know? We know secant, we know tangent, and we know cosine for theta. Okay, we know all three of those functions for theta. So tangent of theta equals sine of theta divided by cosine of theta. Well, we know tangent and we know cosine, right? So tangent of theta is root 15. Sine of theta is what we're looking for. Cosine of theta is 1/4. Okay. Now, a few different ways to think about this, but let's do it like this. So if you divide by 1/4, what are you really doing? Well, sine of theta divided by 1/4, that's the same thing as multiplying by 4, so that's 4 times sine of theta. Okay. So now we can divide both sides by 4, and then we'll end up with root 15 over 4 equals the sine of theta, because these 4's cancel. So yeah, if you wanted to, you could have just multiplied by 1/4, multiply both sides by 1/4 over here. Nothing wrong with that, totally fine. Maybe I just should have done that instead. But anyway, either way, you'll get root 15 over 4 for sine of theta. So this is root 15 over 4. Okay. So cosine of theta is 1/4, sine of theta is square root of 15 over 4. So we said there's a shorter way and a longer way. This is the shorter way. Let's talk about the longer way now. So what if we didn't know the tangent? Then we couldn't really do that, right? Oops, we're still looking for sine of theta. So what if we only knew the cosine and not the tangent? Well, then we could do it this way. So remember that other Pythagorean identity, which we said was one of the most important identities in all of math and something you should always remember. So cosine squared of theta plus sine squared of theta is 1. So we know cosine from part B, okay, it's 1/4. So 1/4 squared plus sine squared of theta equals 1, right? So again, I just want to go through this to show you that there are multiple ways of doing this and you'll get the same answer each way. So 1/4 squared is 1 over 16 plus sine squared of theta equals 1. So subtract 1/16 from both sides, so you get sine squared of theta equals 1 minus 1 over 16. Okay. So we want to do a common denominator thing here. Okay, so sine squared of theta equals, common denominator is going to be 16. So this is going to be 16 over 16 minus 1 over 16. Okay, so 1 is the same thing as 16 divided by itself. So then we have that. So now sine squared of theta equals 16 over 16 minus 1 over 16, that's 15 over 16. Okay. So then we take a square root of both sides. And again, there's a positive and a negative root, but remember, since theta is acute, the sine of theta has to be positive. Because for acute angles, you can think of them as angles in a right triangle, and the sine is the opposite side over the hypotenuse, which is a positive number divided by another positive number. Okay. So we're only going to have the positive root. So this is root 15 over 16, which is root 15 over root 16. Root 15 can't be simplified, but square root of 16 is just 4. Okay? So root 15 over 4, well, hey, that's the same thing we got when we did it the shorter way, right? So we see that this is a little bit longer, but we do get the same answer. And if we didn't know the tangent, that's what we'd have to do. Okay? Or we could figure out the tangent and then go about doing it the shorter way. But that wouldn't really save us a whole lot of work. But anyway, just some stuff worth mentioning there. Okay, so now, let's see. So that's the sine of theta. Now part D is the secant of pi over 2 minus theta. So how are we going to do that? Well, remember, that's going to be the one that uses the complementary angle theorem. So remember, the complementary angle theorem said that co-functions of complementary angles are equal. So we want the secant of pi over 2 minus theta. Well, the complementary angle theorem tells us that, hey, that's equal to secant of pi over 2 minus theta is equal to cosecant of theta. Okay. Well, do we know the cosecant? Let's see, we have the secant, we have the tangent, the cosine, and the sine. So we don't exactly have the cosecant, but does the cosecant, is that related to one of these guys that we know? Yeah, so remember our reciprocal identities? Cosecant of theta is the same thing as 1 over sine of theta. Okay? And So in other words, cosecant of theta, that's the reciprocal of the sine of theta. And we just found out that the sine of theta is root 15 over 4. Okay? So if we want the cosecant, we take the reciprocal of root 15 over 4. So let's zoom in on that a little bit. So we just take the reciprocal of root 15 over 4, and that's going to be 4 over root 15. Okay, so cosecant is the reciprocal of the sine, so that's going to give us 4 over root 15, which is a totally acceptable answer if you were one of my students, but if you have to rationalize the denominator, then you would multiply by root 15 over root 15, and you would end up with 4 root 15 over 15. And again, I don't really believe that this is any more simplified than this, but whatever. So this equals 4 divided by root 15. Or if you have to rationalize, or if you really insist on it, that's going to be 4 root 15 over 15. Okay? Okay, so that's that. Let's zoom back out a little bit. So that's example 5. So notice we didn't talk about, we talked about a little bit, but we didn't draw any right triangles at all. We only used identities. Okay, so we used, for part A, we used that Pythagorean identity that said 1 plus tangent squared of theta equals a secant squared of theta. Okay. And then for part B, cosine of theta, we used the fact that secant and cosine are reciprocals of each other. Okay. And then part C, we did that 2 different ways. And part D, we used the complementary angle theorem. So for examples like this, you can use right triangles, you can draw right triangles and use those, or you could use these identities here. Okay, so that's example 5.